So we're going to talk about just solving log equations or exponential equations. I'm going to put 3 different examples on the screen, on the board. I want you to work them out. These are several of the different types that we've done earlier. Okay, so these are specifically related to the logs. Towards the end, we'll go back and talk about the exponentials. But take a few minutes, use your log properties, use the examples we talked about earlier in class, and see if you can work these out. Some of them are very easy. A is a very simple question. B also is actually easy, and C tends to be a little more work involved. So try those. All right, look at letter A. You have log base 10 of x squared equals 6. The base is 10. Why? It's called the common log. That's the only log that doesn't have to be written down. If it's not there, you automatically put it as 10. Right? Remember the 2 cubed equals 8? Okay? We're in the log base 2 of 8 equals 3 form. We want to be in the 2 cubed equals 8 form. So convert that over, and you get that 1 million, or 10 to the 6th, equals x squared. I just wrote 1 million. So after that, I want to get x, not x squared, so I square root both sides. The square root of 1 million is 1,000. And so you have plus or minus that result. And I try to plug it back in. Because I have an x squared in the log, when I plug it in, the negative 1,000 squared is still 1 million. So I don't have any problem with the negative 1,000. And that's how you would solve part A. Any questions? Okay. Part B. Here's part B. In this example, I chose to go the route where I wanted it to be a log on one side equals a log on the other side, rather than condensing and turning it into an exponential. Either way, we'll still get you the right answer. Okay, so in this case, when I subtract it over here, I got the natural log of x on one side. Because it's the natural log equals natural log, notice where the 1/2 went. We started with the 1/2 in front, but I went ahead and brought that up top, and you want to do that all the time. You don't want to have something out front when you drop the logs. It needs to be just log out front. Right? So I drop the logs, and you're going to get this equals that. Right? It's x plus 3. The square root of x plus 3 equals x. To get rid of that square root part, I square both sides. I have to get the x outside of the radical. The only way to do that is to square both sides. So when you square both sides, you're going to get x plus 3 equals x squared. Here again, we're in a quadratic situation. So if I can factor, I'll factor. If I can't, I'm going to use the quadratic formula. And so I went ahead and put everything on the right side. Why did I go to the right side rather than the left side? Because everything was on the left except for x squared. I'd like to have a positive x squared. Go ahead.
Why'd you square root it?
Question was, why do I square root it? Okay, good question. Because what we ended up with was x plus 3 to the 1/2 is the square root of x plus 3. And so I need to get the x out from under the radical. The only way to get out from under a radical is to do the opposite of that. Well, the square root's inverse is to square it. If it had been cube root, then I would have cubed it. Okay, whatever root I have to undo the root. In that respect, that's why I square rooted it. Once I got towards the end, I went ahead and wrote out a, b, and c, plugged it into my quadratic equation, and worked it out. Notice at the bottom, I don't have the plus or minus sign. I just have plus. Let me stop for a minute here. If you're working a quadratic equation out, and you get to the point right here where you get the radical sign, the radical number, mine happened to be 13, but if you got a negative radical, you have enough evidence to stop and say, that's going to be imaginary. There will be no solution to this. Okay? So that's enough work to do that and be done with it. So don't waste your time solving and getting I's and stuff. I'm not going to look for that. Okay? Get to that point, say no solution. Okay? Now, why did I drop the negative? It is extraneous, and how do I test for that? If you take 1 minus the square root of 3, I don't even know what the square root of 13 is, actually. But I know what two numbers it's between. Can you tell me? It's between 3 and 4 because 9 and 16 are 3 squared and 4 squared, right? So 1 minus 3 or 4, say 3.5, is a negative value. And if you go back to the original part here, if I plug a negative number in for x, it's automatically going to make it extraneous. It'll give me error. So I throw out the negative one, 1 plus the square root of 13 over 2. And by all means, give me the decimal answer there. I don't need it to be the fraction or the radical. It's fine. I don't care. Okay? So you can solve it that way. Any questions on B? Good? What about, have you had a chance to work C yet? Any more time?
Yes.
Okay, work C. For part C, the first thing we do is you recognize here where you have the 2 logs on both sides, on this left side. So in order to drop the logs, I need to do a little bit of simplifying. So I'm going to drop, or I'm going to condense this side into this log of x minus 2 times x plus 5. On this side, I need to get rid of the 2 out front, so we bring that back to the exponent for 3. And so you're going to get log of 3 squared. Because it's a log of something equal to the log with the same base of something else, I drop the logs and you get this little quadratic formula here. And I went ahead and did 2 steps at once. I went ahead and FOILed and multiplied these 2 parts together to get x squared plus 3x minus 10 equals 9. And then because it's quadratic, I want to get everything on one side of the equation. Try to factor if I can. 19's prime. 19 doesn't factor but into 19 and 1. I'm not going to get a 3 out of that no matter how I work it. So go directly to the quadratic formula. Don't waste your time. And if you work that out, you're going to get, I believe it's, was it negative 3 plus or minus the square root of 85 over 2?
Yep.
Yeah.
If you try the negative minus the square root of 85, you're going to get a negative 6 something. If you plug that back in, if I plug it into either one, it's going to make that a negative value inside that log. So automatically, the negative value won't work. So it's only the negative 3 plus the square root of 85 over 2. Or you can see here we have x equals 3.1. Okay, that's a very typical type question. Okay, so you should be prepared to do things like that. Any questions on how we did those? I got a couple more to try. What? Okay, so let me put some more up, another one up, and you work on this one too. Try that one. So if we go back, I mean, in part A, it was really nice. It's log of something equals log of something, the same basis. So I just dropped the logs, solved the equation, and got x equals 3. It was easy. I didn't even need to think about plugging it back in because it all works. In part B, I need to do a few things. First of all, I'm not going to be dropping logs because why? I only have one. In order to drop a log, in order to drop them, I have to have a log equal to a log. Now I could do some fancy algebra and properties of logs and get to if I really needed to. Gio was trying that a minute ago. Did it work out? Yeah? And so, we'll see. What I would do, first of all, I need to get that 2. I'm going to raise it to the power up here. Right, so it's going to be that all squared. And then I'm going to take my 7, and I'm going to turn this into an exponential. So it's 7 to the 0 equals that negative 2r squared. And so it would look like this. Okay, let me explain each step. So first step here, look, right here. Let me back it up. Okay, and so what you see is I simply, I changed the 2. I took that 2 and I put it as an exponent. Now, there's nothing else really to be able to do until I convert it to an exponential form. So right now, I'm going to take that 7, base of 7, and raise it to the 0 and have it equal to this whole bit. But what does negative 2r all squared end up becoming? Careful. It's 4r squared. Don't forget about the number. R squared, yes, but the number is inside that parenthesis, so you have to square it too. Right? So if we do all that, you get this thing. At that point, well, 7 to the 0 is just 1. So I'm going to set 1 equals 4r squared. What would you do from there?
4.
Divide by 4. Yes, sir?
What should you do like with the exponent
Okay, that 2 right there. I squared negative 2 and got 4. And I squared r and got r squared. I squared that all both parts. This, I said, you take 7, raise to the 0 power, and it's equal to what's inside. So that's how we come up with this equation. And I'm going to take the square root. So square root, and you're going to end up with plus or minus 1/2 r. 1/2 equals r. But at the end, I circled only negative 1/2. Why did we throw out the positive 1/2? Go back to the original. If I plug in a positive 1/2, it makes it log of negative 1. Nope, not a possibility. Throw it out, and so you're left with only 1/2. Negative 1/2 is a possible solution. Any questions on that one? Okay, so there's one real issue that I want you to make sure you remember. Anything to the 0 power is 1. And when you square items inside of parentheses, you're squaring every little term in there. Okay, so don't forget about that. Here's another one. Okay, how have we changed gears here? What are we doing? What kind of equations are these? Okay, these are exponentials. So there's a potential of changing to logs. That's one method. Or, like in example 1 we did today, if I can get the bases to be exactly the same, I'm kind of shortcutting all that work and working it out that way. So take a few minutes and see if you can work this one out. This one, this is kind of traditional. You should expect to see these kinds of things. I'm going to give you 2 numbers, and one of them is going to be either in the base, or you're going to see something, oh, these all have the same root number, right? In this case, you have 3 to the 1 minus 2x. Since 3 is prime, it has to be the base. And so 243, you think, well, is that 3 to some power? You hope it is. If it is not, then you have to take the log of both sides and go from there using a base 3. In this case, it worked out nice. It's 3 to the 5th power. So I'll go ahead and I just take the exponents, set them equal to one another, and solve it like a real basic equation. Remember, this is a shortcut. This is the easy method. If you can do it this way, you want to do it this way. Not all of them can be done this way. Okay? If you can't get the bases to be the same, and sometimes you can't, you would have to take the log of both sides using, in this case, I would have to use a base 3 because that's where my x is. All right, here's another one. This one's a little tricky. All right, so we said 1 can be any base you want it to be. Because it's any base at all to the 0 power, because anything to the 0 is always going to be a 1. So this is what you'd see. Take those, set it equal, solve, and you get 2/3. Is it important that I go back and check my answers to get extraneous roots for exponentials? No, I don't. Because the domain is all real numbers. Logarithms, if you take just log of x, the domain is x is greater than 0. So you have only half the number 9 to work with. So there's a lot of values that might get thrown out. So I make sure on a log to check. On exponential, I mean, it is possible to get no solution, but I'm not so concerned with it. Here's some others. Okay. Don't let that one throw you off. Okay? That's all smoke and mirrors. It's a lot of numbers. It's big numbers. But look at all the bases, all the big numbers. What do they have in common? 9. They all have factors of 9 or 3. So take a few minutes. This was a good one to work with. Let's see what you can come up with. So in this example, now there's a lot of ways you can do this. Okay, I'm going to try to take the most direct approach to it, but I've seen several ways today, and they're all great. So what I did was I divided by 81 first, and to get my base with its exponent on one side by itself. So this is what it's going to look like. Okay, so we divided by 81. We're going to have 9 to the negative 2b minus 2 equals, what's 27 over 81? It's 1/3. So let's write that as 1/3. And so the question is, I can't write 1/3 as a power of 9. But I can write 9 as a power of 3. Can you write 1/3 as a power of 3? How? Perfect, -1. Good. And so here we have -1 as my exponent. I have 3, I've changed 9 to 3 squared. That poses another issue. How can I take the 3 squared to the -2b minus 2? What do I do with those two exponents? We multiply them because it's power to powers. So go ahead, multiply those in the next step. That's what I did. And so we went ahead and multiplied -2b times 2, -4b. -2 times 2 is -4. And 3 to the -1, so I set the exponents equal. Solved it. In this case, it's a nice, simple little equation. Okay? There are shorter ways to get the answer, but it requires you to use more properties of exponents that some of you may be comfortable with. But if some of you saw that and some of you mentioned it to me, okay, great, fantastic. The more properties of exponents and logs you are comfortable with, the easier this becomes. It opens more doors for you than others will have. Questions? Okay, we got one more, we'll be done. One more log and we'll call it a day. Let's work this out. Right, so I'm going to condense. Which way would you like to condense? You know, I'm going to subtract the 3 on one side. Since I have an x on one and numbers on the other side, I'm going to do this. The natural log of 4x squared plus 9, that's all on there, equals the natural log of 30 minus the natural log of 3. Now, why would I do that? Because 30, if I subtract logs, what kind of operation does that change into? It's division, and 30 divided by 3 is nice. That's 10. So we can say the natural log of 4x squared plus 9 equals the natural log of 10. So what could have been kind of a frustrating problem is not that bad once you see what you can do. And if you did it the other way, it would have been a big deal. I'd have multiplied together, set them equal, and then I would have eventually divided by 3 again, and it would have worked out to be the same thing. So then we have 4x squared plus 9 equals 10. And if we do a couple things together, I'm going to subtract 9 from both sides. And so I end up with 4x squared equals 1. And then we have x squared equals 1/4. And x equals plus or minus 1/2. And I go back to the top. And I look at my problem. And I look at the x. It's squared, right? So is there going to be an issue by plugging in the -1/2? No, it'll be positive 1/4 when I work it out. If I plug in the positive 1/2, it's also going to be fine whether it was a square or not. So in this case, both of them worked out. So you have options, you have the freedom. As long as you don't break a mathematical rule, everything's kind of fair game. So be careful. Okay, make sure you practice these tonight, and we'll do some more tomorrow.